Hello and welcome to the Chartered Association of Building Engineers webinar for November 2018. Today we are looking at the retrospective application of BS9999. My name's Katie, I'll be the moderator for today's session and I look after all the IT and the digital side of things here at CABE. So how to interact with us. Now, if you're familiar with our webinar sessions and how we run them, we do tend to like them to be nice and interactive with you sending in questions. However, due to time constraints this month, we've actually pre-recorded this. So whilst you obviously are hearing this live, it's not actually going out as a live broadcast. But that doesn't mean that you can't still get in touch with us. You can still actually send in questions as part of this session. So you just use the question panel that's either to the right or to the top of your screen, type in any questions, and I will receive a notification of those, and I'll be able to download them and go through them. And what we'll then do is I will forward those questions onto the speaker for you to then have further conversations. Similarly, if you're watching this on our YouTube channel, you can send any questions in via email to info@cbuilde.com. If you're on Twitter, we have a hashtag CABECPD. So your presenter for today is Jamie Davis. Now, Jamie is the head of fire risk management for BB7, running a large team of consultants who provide specialist advice to a diverse range of clients. Prior to this, Jamie had a career within Kent Fire and Rescue Service within both operations and fire safety enforcement. His last appointment was lead investigation and enforcement officer, working closely with legal counsel. He then transferred to the private sector, having obtained a first-class honours degree in fire engineering, originally working for CS Todd & Associates before transferring to BB7 as a senior fire engineer. Jamie has acted as expert witness for several civil litigation cases and has many ongoing cases that he's currently providing technical advice for. He is a member of the Institution of Fire Engineers and he is a chartered building engineer and currently sits on the board for CABE. Jamie, when in his spare time, is also studying for a master's degree in law, and he has a passion for the subject of fire safety regulation. So what I'm going to do now is I'm going to hand over to Jamie, and he will then take you through this session. So just one moment.
Okay, we all good?
All good, all yours.
Fantastic. Thank you, Katie. Good morning, everybody. As Katie's said, I'm Jamie. I'm going to take you through this CPD session of the retrospective application of BS9999. The purpose really of the presentation is to give you a bit of an overview to how the standard can be applied retrospectively, and just point out some of the differences maybe between 9999 and documents that you may be working with a lot more, such as ADB, and some of the differences which really should be aware of when looking to apply the standard. Most of you will probably be aware that within 9999 there isn't actually like a guide, I suppose, how to apply this retrospectively. Although it can be done, and it has been done, and the document itself infers that it can be done. So really it's just to take you through the approach, really, the things that you should be considering when looking to use the document in that way. So really I'm just going to take you through perhaps where we've been to begin with, and looking perhaps a bit of the history of 9999 and where we are. Certainly those of you who may have worked in building control or building engineering, certainly in the early years, may have been used to such documents as post-war building studies, which led, as you know, to the 5588 series from part 0 to part 12, which were all superseded with the exception of part 1 into the 2008 edition of 9999, and we're now up to the current standard, which is the standard we're going to talk about a bit today, which is the 2017 9999 edition. We do touch a little bit actually on the 2008 and some of the differences between the 2008 and 2017. So there were quite a few differences in the document, but there are a few that we've got to be a little bit aware of when looking to apply the latest standard retrospectively. And in particular, one of my case studies just does talk about some of the issues which were encountered because of that. So what really was the purpose of 9999, and where did it come from and what did it bring? Well, obviously the most I suppose standard approach really of designing buildings to a fire safety aspect is approved document B, and that's a document which I suspect that most of you are very familiar with. looking at a more advanced approach, obviously we can use the 9999. It's a much more detailed design document, which I'm sure you're aware, which gives you a lot more guidance and of how to design buildings, really, taking fire safety into account, covering a lot more areas which ADB never did, going up to fully fire engineered, fully advanced solutions, designing a building from scratch, really. And what 9999 does is sort of sit in the middle, really. It takes some of the principles from the 7974 series here and a lot of the fire engineering approach to things and calculations, and also taking a lot of the guidance from ADB and sort of puts the two together to create this advanced approach, which we're going to talk about a bit today. The big thing really with 9999 and what it did in difference to ADB was take risk into account. 9999 takes a more risk-based view, as I'm sure you're aware, and some things which we can talk about a little bit later in this session. Certainly, what 9999 did was take all of the 5588 series, as we said earlier, but with the exception of part 1, which sat outside of 9999, that actually went into 9991, which dealt exclusively with residential buildings, which, although are touched on in 9999, don't necessarily go into a massive amount of detail. That's covered in more 9991. Certainly, it gave a much more design consideration when we think about risk assessing buildings and taking the risk into consideration. Depending on the use of the building, really, that's been layered all through the document in respect of means of escape right up to firefighting access, dealing with parts B1 to B5 of the functional requirements. 9999 did that in a much more inclusive way, I suppose, than what ADB did, because ADB certainly doesn't take risk of the purpose groups to any great extent into account. And of course, as we said, the 2017 edition replaced the 2008 edition, which amended, refined, maybe corrected a few mistakes in the document, but we've now got it to a much better place to what it was. So why would we look to apply 9999? I mean, there are benefits in applying the document. And one of the most ones which certainly when looking from a retrospective point of view, which is asked quite a lot, is increasing occupancy within the buildings. I mean, certainly what the standard did was take into account the risk of premises aren't the same, certainly as ADB doesn't allude to, certainly within occupancy calculations. So ADB is very different to 9999 in that way. The standard also gave us better design freedoms, really, with around having sort of increased travel distances, smaller escape widths, decreased levels of fire resistance, for just a few examples. There are many within the document. So there were great benefits with, or there are benefits, shall I say, with using 9999 rather than ADB for some buildings. So why would you look to do a retrospective application? Well, there's quite a few, but the main ones really that we tend to come across, there may be an extension or an alteration to an existing building. So perhaps the new design is using the standard 9999, where perhaps the previous areas of the building were designed to a previous design standard, such as ADB, and we might be looking to bring the whole of that building into the use, or certainly under the design principles of 9999. Perhaps a review of occupancy. In fact, this is probably the most common one which we get asked to look at, particularly when looking at retrospective application. So looking at the increase of occupancy, basically, very common within office environments, particularly in the city, where they want to put more people in the buildings, quite frankly. So they'll look at ways in which that can be achieved. One of the most simple ways, obviously without spending loads of money putting in additional escape routes, is looking to be able to use 9999 to review the occupancy of the building as it currently is. And there might be some considerations, obviously, which we'll talk about as we go through the document, but that's probably one of the most common things that we get asked to do a review for. Change of use, potentially. They might, with changing the use to a different occupancy, they might look to use some of the benefits from 9999. Perhaps as an installation of a new system, perhaps a fire alarm sprinkler system. Obviously, we know that the standard can give us better design freedoms by utilising those things. So that may be a reason as to why we're asked to look at something retrospectively. But also looking perhaps at existing buildings, like heritage buildings, clearly, heritage building built a long time ago is never going to comply to anything that we've got of today's standard, but using some of the principles of 9999, we might be able to get a heritage building to perhaps look a bit more compliant, shall we say. And I've certainly used that on a few heritage buildings, particularly museums, to use some of the design principles within 9999 to ensure that they can actually take the occupancy and the amount of people that they need to be taking within them. And also, something that we shouldn't forget, there's some good principles in 9999 perhaps for informing fire risk assessments, particularly where we've got a non-compliant building, and using 9999 to be able to better inform, should we say, risk assessment process, taking factors into account such as ceiling heights, provision of automatic fire detection, that sort of thing. So how should we use the document? ADB is quite clear, 9999 is quite clear, should we say, of how the document should be used. When we look at the document, how it's split down into the 4 main groups, obviously we have fire safety management, means escape, structural fire protection, and firefighting access. All of these areas, should we say, they integrate to each other, and it's really, really important to understand how they integrate. So the standard's very clear that we shouldn't really be cherry picking to take off bits that suit us without having very due regard for all the other areas of the document. As it says in the document itself, the key thing here really is what we're trying to get across, is that if you're going to use 9999 for any form of retrospective application, that's fine, but be very clear in your understanding of how one area of the document may have an impact on other areas. So it's really understanding about how the document sections interact with each other here, and being very clear that you're competent in order to understand why something may impact on each other. That's what the standard's trying to say here, and I think it says it quite well. Okay, so obviously when we're looking to review building against 9999, we have to absolutely remember that the key objective here is to satisfy the functional requirements of the building regs and obviously the fire safety order, to ensure that, or other fire safety legislation as it may be in the UK, to ensure that actually we're complying with the law. It's not just about broadly trying to get a building to fit a standard because that works. We really need to understand, is what we do, is it actually complying with the law? That's the key thing, what we're trying to achieve here. So when we look at the standard then, the first thing really that we should be doing when looking to apply it retrospectively is understand how the building may comply with the baseline provision of what's required within the standard. So the first thing we sort of need to be asking is actually what are we trying to achieve from this review? When we think back to a few slides ago, we're looking at potential reasons to why we may have applied this standard. Of course, we need to be thinking, what is the actual thing we're looking to achieve through the purpose of this review? It may be, as is often the case, as we said, that it might be an increase of occupancy. Well, if that's the case, then the means escape section is really critical, and that's something we really need to be considering, that everything complies within reason to the document. So it might not absolutely be necessary to have to apply all of the document in all cases. It may not be that a means escape issue, that the bearing of a reduced or an enhanced level of fire resistance might have not any really bearing on the means escape issues. But equally, it might be that if we're looking to decrease structural fire protection through a retrospective review, that firefighting facilities could be very relevant, actually. So it's really understanding, again, that interaction between the standards, understanding what the purpose of the review is, and then looking to apply the various areas of the document that are relevant. Due to time constraints today, we're going to look primarily at means escape. To go look at all of the baseline provisions through the document, as I'm sure you agree, would certainly take longer than a morning session. So we're going to look primarily at the means escape section just now. But you should be able to get the idea of how we're looking to apply the document, to get how we're looking at it really. So obviously, those of you familiar with the document, the first thing that you'll be looking to do is apply a risk profile to the building. And how we do that, as I'm sure most of you are aware, is looking to look at what type of occupants are within the building based on if they're awake and familiar, if they're awake and unfamiliar, who are asleep, etc., etc. And these are sort of some examples where you may find these type of occupancy characteristics, but you'd obviously need to assess the building to understand which one you're going to apply. Secondly, you look to apply a fire growth rate, 1 to 4, but it's key to note that we don't cover 4 within 9999. Ultra fast fires are outside the scope of the document. So in reality, we're looking at 1 to 3. So that's based on the fire growth rate, so how quickly the fire is going to grow within the premises. The key thing to understand here as well is if the building is fitted with sprinklers, and they should be a life safety sprinkler, which was changed in the 2017 edition of 9999, you will actually drop a fire growth rate. So if you look at an office, for example, which would usually sit in a fire growth rate of 2, being a medium, having sprinklers would actually drop that into a 1, into a slow growth rate. So then you'd be able to look at your risk profile, which is here. So if you had sprinklers, then you drop into lower 1. So what you'll end up here is a risk profile based on what you've assessed, A1 to A3, B1 to B3, C1 to C3, whatever. But that then sets the baseline really of what you follow through the document. So now what we're going to look at is just an overview really of what the document suggests and requires within baseline provisions. I'll just talk about a couple of issues around these. So these are things we're going to look at. There's that's the baseline provision for 9999 before we look at any enhancements. You notice there that I have actually omitted firefighting equipment. That doesn't fall within the scope of a means escape provision. The reason why that's omitted is firefighting equipment, as we know, isn't there to form a means of escape. It's a bit of something which people quite often mistake. They believe firefighting equipment is there to aid means of escape. That's absolutely not the case, and that's iterated within the document as well. So that's why it doesn't include itself within that provision. So the first thing we look at then is the fire detection and alarm system. Now, looking through the risk profile, as you have already determined, you'll notice that the standard applies a minimum acceptable detection and alarm system standard, depending on the risk profile. So such as an A1, a very low risk premises, for example, a category M system might be perfectly acceptable under the standard. Quite often, as I'm sure you agree, in my experience, you rarely find Cat M systems being newly installed now, certainly not the case. But this will provide you the basic minimum acceptable standard, what's required under 9999. So this is what we're looking to achieve when originally assessing the building. So at this stage, we're assessing the building to see if we can apply 9999 in the first instance without doing any additional works. Escape lighting, again, I shan't dwell on this too much. It's very, very similar to what the requirement is within ADB. In fact, it's virtually identical. So it would be to the relevant standards, 5266. So that's what you'd be looking for. And same with signs, very, very simple, that any exit signs which are within the building should be compliant to 5499. So then we start looking at perhaps the door fastenings, direction of opening. Most of these, to be fair, are very, very similar to ADB, so we shan't go too deep into them, but ultimately all exit doors should be opened without the use of a key. And if there are any electronic locks, they should be fitted with overrides, etc., to conform to BS 7273 Part 4, so that the electronic lock should fail safe, basically, or fail to open, should I say, on fire alarm operation or loss of power from the system or a system error. And they should also be fitted with a manual door release as well to the side, the little green boxes. There are occasions, however, where manual door releases aren't fitted based on a risk assessment of being that the higher risk actually is a security failure than a means of escape failure. Something like block of flats, for example, but I know that's not necessarily covered in 9999, but sometimes it's more favourable not to have a manual door release where it's going to be broken in 10 minutes and that door's going to be constantly open. So there are times where you can suitably justify that a manual door release may not be required, providing the system is configured in the correct way that it should still fail safe. Again, simply very, very similar to ADB. In fact, it's actually identical, I think, to 5.14 in ADB. That where we've got door fastenings and the direction of the opening of the door, that the door should open in direction of travel when you've got an excess of 60 persons, with the exception of if you've got any areas which may be rapid fire development. Now, that's not necessarily intended for kitchens. That's more sort of for industrial areas where you may have very high fire loadings, or can contain such things as alcohol, solvents, whatever, which might give very, very rapid fire development, and a quick egress may be required. So looking what the provision would be for final exits, again, very, very similar to ADB this, but there are perhaps a couple of minor issues, particularly, or differences, should I say, when we come into perhaps merging flow calculations, that there are quite a few different examples of merging flow calcs within 9999, but simply, final exits should be sited away to ensure that there's rapid dispersal from the building. They should be easily apparent. They should be sited away from smoke outlets and vents. Sometimes a little bit difficult with existing buildings, particularly in the city, particularly with basement vents. But this is something that we try and achieve if we can. This is something which is different slightly within 9999. It's about the provision of having, if you have external steps, ensuring that you've got adequate space outside. So if a wheelchair needs to come through, that it can be put to a side if you've got other steps to climb, and it's not necessarily going to obstruct egress until we've got people who can assist to take the wheelchair or the wheelchair user upstairs. And obviously any exits which should be provided, that it can take all relevant merging flows. Now, there are 3 different merging flow calculations within 9999. They're figures 6A to 6C. I'm not going to run through the calculation process today, but just be aware that they are there, and you may need to apply them. Again, identical to ADB when we talk about the layout, perhaps the number of escape routes, defining how many people and the minimum number of escape routes you would ever require. That's quite simple, table 10. This is slightly different, the old 45-degree rule. ADB, as you know, the 45-degree rule and how that's applied within ADB is pretty much from the furthest point. If your exits are less than 45 degree, then that they should either be separated or made wide or whatever. But 9999 approaches this in a different way slightly, or something you can do. It's very similar back to the old angle of divergence, if anyone's old enough to remember that. But what this does effectively is decrease, makes the angle more acute effectively, if you can combine travel distances. So effectively, if the distance between A to D is conforming to a single direction of travel, and the overall A to B or A to C is actually still less or within the agreed travel distances, then you can have an angle less than 45 degrees. So providing, if you'd be measuring your angle effectively from point D, from B to C, providing this distance here is no less than a single, is no more than a single direction of travel, then it is allowable. And that is a big difference between ADB and 9999. I'll brush over some of these because this is quite a big section, but also things that are very, very similar to ADB. Obviously, single escape route should not exceed more than 60 persons. We know that. Inner room considerations, identical to ADB, the types of control measures which you may have there for inner rooms, detection vision panels, gaps above walls to ceilings, etc. With the central core considerations, we've got the picture up here just to demonstrate that what we should have is separation between the 2 lobbies, so you shouldn't pass into the same lobby to approach into the same staircases. That's the idea of what that's trying to achieve. Circulation routes as well, we obviously try to keep them away from stairways, exactly the same as ADB. And when we think about different uses and different occupancies, we try to provide different escape routes for different uses and different occupancies. Meaning really that we shouldn't be having escape routes pass through different occupancies. That's not really the done thing. Height of escape routes, same requirement as ADB. 9999 gives a bit more description around corridors, about their enclosure, recesses, etc., around subdivisions. So it's quite good familiarising yourself with this area, just to understand if that could be relevant at all to what you're trying to apply it to in a building. particularly with a building you're applying it to retrospectively, are there any deviations or variations from the standard which are going to affect what you're trying to achieve? That's what that's looking to deal with there. External routes, predominantly routes over roofs, is what this section in 9999 deals with, and it's looking at the standard 3 meter separation from anything. If you could have on either the roof, might have vents, windows to a wall even, or a door within a roof escape, should be within 3 meters. There's a slight difference to ADB there, so it's certainly worth familiarising yourself with that area. And if not that I've ever done it, but if you're applying retrospectively 9999 to a building that uses progressive horizontal evacuation, ensure that the provisions, in respect of compartmentation and that are there. Travel distances, obviously, you've spoken about a little bit earlier. Again, I'm sure many of you are very aware that in 9999, they're very, very different to what ADB would be, that they're all based on risk profiles, so having a direct or actual distance. Meaning that you can apply the 2/3 rule as you would do in ADB. So if you're measuring direct, you'd look at 44, or if actual, it would be 65. In reality, in existing buildings, this is the one you're going to be looking at, is the actual distance, actually measuring it. Direct really is only really useful for design. So actual is where we're going to be interested, either 2-way or 1-way, just to ensure that they're pretty much within those limits. Again, not absolutely hard and fast, but near enough there. Again, if we're looking a bit more at widths of doors and escape routes, again, slight differences here as well to ADB. That probably the most important thing, certainly that they shouldn't be any different to Table 12, as we'll talk about in a minute. So the escape routes effectively need to be not less than the aggregate calculation within Table 12, which we'll talk about. But they shouldn't be less than 850, where there's a potential of wheelchair access. So it brings in some of the Part M requirements here as well, obviously, which ADB does separate a bit more, but 9999 does think a little bit more about disabled use. Probably one of the most different areas here is this one here. This is quite important. 9999 assumes that every door will be at least 800 millimeters, which, when looking at existing buildings, can be a challenge, actually. Certainly, a lot of the buildings that I've looked at, some smaller office buildings, their doors are often less than 800 mil. So we have to apply a bit of common sense and some engineering methodology behind where we may have the doors of 800 mil to see if it's achievable, or do we actually need to widen the door. So this might be a variation which we might have to look at when applying it retrospectively. 800 mil can be difficult to achieve sometimes. So I mentioned Table 12 here. This really gives you your aggregate exit width. So effectively, where ADB, for example, might apply 5 mil per person, it will apply so many millimeters per person based on the risk profile. So if you've got an exit, obviously we're applying retrospectively, that you might have a 2000 millimeter wide exit, you just divide that number by whatever here you're looking to achieve to know how many people that exit can reasonably take. That's how you look to apply that. A big difference between the 2008 and the 2017 standard was equation 1. Now, there's many theories as to how this actually happened, but what the 2008 standard of 9999 did was allow you to apply these standards to any width of door, up to 800 mil effectively. So you could have an 800 mil door and you just divide it by these numbers, which would actually give you a very high number of people potentially using an 800 mil door. So this was recognized in the 2017 standard, and they put a reduction on it similar to the interpolation rule within ADB. So what we do now is, if there's any door less than 1050 millimeters, the approach which we now take is this equation here, equation 1. So what we do is we take 500 and then we divide it by this figure. Okay, so any door less than 1050, that's what we do, which will then give you the number of persons that the door can safely accommodate. We go into this a little bit later, to how that looks like with existing buildings, and also buildings which may have actually been designed quite reasonably to the 2008 standard, where there might be a massive difference now in occupancy calcs. So we'll look at that a little bit more in detail a bit further. Something else we have to consider is the corridors and escape routes. Again, these are all baseline provisions now of 9999, what we're looking to achieve. Again, similar in requirements that the corridor shouldn't be any less than the calculated exit width of what we would have just done, or by no means less than 1200, unless you've got a building where you won't have wheelchair access and you can go down to 1000. And if you've got any pinch points of doors, say cross corridor doors or anything, then they shouldn't be less than 150 mil than the corridor. That's how much you can pinch into the corridor. So if we move into vertical escape, start to look at staircases. This is approached in a very similar way to ADB, but slightly different calculation methodology because of obviously it approaches it in risk factors rather than ADB just looking at it quite simply. So some other things do apply, similar requirements to ADB around limited combustibility, with the exception, however, of it applies it down to risk groups. So rather than saying just residential or whatever within ADB, it's looked at risk groups now instead. So limited combustibility obviously is defined within the standard, and it's worth looking at that to ensure that you're happy what limited combustibility means. Quite often it's confused with just meaning class 0. That's not the case. Limited combustibility can be various materials, providing it falls within the certain test parameters, which is defined within the standards. So I would advise that you look through that to ensure that you understand what limited combustibility means when you're looking to apply it in an existing building. Again, slightly different thing, how external wall protection applies to staircases. It should be 1800 mil fire resisting construction within sort of staircase walls, for example, if the angles are not more than 135. So effectively what that's trying to do there is create or reduce, say, the radiant heat from an angle of a window, shall we say, opposite the staircase, coming onto areas where the staircase may be. But if that angle is more than 135 degrees, it's assumed that the radiant heat will be negligible on the area that you're looking at. The lobby requirement is exactly the same as ADB. So, on single staircases, for example, phased evacuation, buildings above 18 meters, that's identical to ADB. So when we start looking then at the number of stairs that a building may be required, that's going to be based on the number of occupants and building height, obviously. So if we're going over sort of the 11 metre height, we're going to be looking at least 2 staircases, depending on the amount of occupants. And also mixed use buildings. What 9999 is good at here is it looks at effectively risk assessing the building to see whether the mixed use or the different uses within the building actually are an issue. So you might have mixed use buildings which are actually interconnected in some way. So actually, is it necessary to have a totally separate staircase? But equally, you might have a building which has got residential above or a hotel down below, which you might need separate staircases. So what that's saying is it's use a risk assessed approach rather than just defining you must have separate staircases. So this is the equivalent of table 7 of ADB, so table 13 in 9999. It's done in a similar way. Obviously, the difference with ADB is that the figures are all set. So you'll have the numbers of people based on the number of floors based on the staircase widths. That's what you do within ADB. But within 9999, because of risk profiles, it has to be a little bit more complex. So effectively, what you look at is applying this amount of width per person for the amount of floors against a risk profile. So it's done in a similar way, just very slightly different. However, when you look at retrospectively applying it in reverse, there's considerations that we have to be aware of, which we'll touch on a little bit actually in one of the case studies. So we'll talk through that a bit more then. If you've got a building with phased evacuation, unlike ADB, where you've got just a table that tells you what you should be doing for phased evacuation in terms of widths, we generally assume 2 floors evacuating on a phased evacuation. So what 9999 does is steer you down the route of ensuring that you use this figure here, effectively the 2 floors for a phased evacuation. Again, stairs going into basements, very, very similar to ADB. The fact that the stair should always really be separated from the main stair, unless we've got smoke control systems, or if it's a small building, sort of less than 11 meters, if there's a fire resisting lobby at the basement lobby. or a separation of the basement level in the staircase, so a physical screen effectively within the stair. For small buildings, that's allowable, but for larger buildings, we can have one stair that goes down to the basement if the basement corridor, sorry, the basement lobby is vented. That's what we'll be looking to achieve with that. So they're really all the main sort of physical things that we'd be looking at in terms of the baseline provisions to see if the standard can apply. You know, is it massively outside of this, or is it broadly where it needs to be? But perhaps one of the most important things really, which sits within 9999, is this area, and that's management. Management was actually quite bolstered up within the 2017 edition because what it recognised was the management levels, you know, within the 2008 standard didn't quite do what they were meant to, and arguably it was impossible to achieve level 1, which was apparently the best standard, and level 3 didn't really comply with the legislation. So that needed changing. So what we come up with really was 2 management system levels. Management system level 2 means that you comply with the absolute minimum requirements of the legislation. Quite simple, you think. However, from my experience of auditing organisations, and certainly as a case study we'll look at a little bit later as well, I've never found an organisation that fully complies, to be honest. There's always something which might need a little bit of work to get them where they need to get to. So that being a requirement, at least being level 2, that you'd be doing a management assessment, and it's really important, particularly when we're looking at putting large numbers of people above what standards guidance would allow. We need to ensure that management is really, really good to ensure that they're not putting those people at risk. So it's really, really important that we assess fire safety management well. There is also management system level 1, which is enhanced. It can give you some benefits within the document, especially if you're looking to say have any variations from the document. We'd be looking at a significant demonstration of good management, and the way that the document requires that is conformity with a management system such as PAS 7. So we'd be looking for very much enhanced level of management, which goes above and beyond, as you say, the requirements of legislation. But certainly with any retrospective review, we would definitely be looking at ensuring that the management's good, effectively. So what if you've got a building then that doesn't comply to any of the baselines which we've just spoken about? Well, of course, there's a few things to consider around this. I mean, we obviously want to avoid the cherry picking aspect, but equally we might need to do a risk assessment to see how much of a bigger deal it is when we're looking at all the other areas of the building. So, of course, the first thing we need to be asking is, does it satisfy functional requirement? Now, it may not always be possible to determine that without further work, but that's obviously what we're looking to achieve, as we said earlier. It may be the case that perhaps we need to engage with the fire engineer. Perhaps we need to start doing something a bit more advanced, and it might go a little bit beyond what 9999 requires, but might be still using the principles. But of course, we do have to ask ourselves, actually, is 9999 suitable to actually put to this building? I'm not sure. Yeah, there have been some buildings before we've been asked to look at it from 9999, and reality is it's just not so suitable. There are some types of building, particularly when management is just so far off that it just doesn't give you the confidence that applying 9999 is a good thing to do. But it might also be the case that you put in place an action plan as well. So if you could, in theory, apply 9999 if you rectify these issues. So that's something that you could do as well. So that's the sort of approach really that you'd be wanting to look at if you have a building which doesn't comply fully with the standard, effectively. I said we'd come back and have a look at equation 1, because this is quite the case what you might have in a building that doesn't comply with the 2008 versus the 2017 standard. Now, probably the most important thing to take away with this is that I think most of us probably know, who are familiar with the standards, is that a building designed to the 2008 edition of 9999 wouldn't comply with 2017. It would actually be quite different. So I think we have to ask ourselves, really, when we look at the perhaps even the legal point of view on this, is what's reasonable in the circumstances. could we do a risk assessment to ascertain if this increase in occupancy is okay, if it's not? And obviously each building is going to be dealt with on a case-by-case basis. But I think the way we have to look at this, taking, again, the legal point of view really, is it any different to when guidance has been changed or superseded in the past where the standards have been so far different? For example, the example used there is CP3 versus 5588 Part 1. I mean, when we consider what within flats, what the smoke ventilation requirements were in CP3 compared to what they are now, they're massively different. They're hugely different, and that's been recognised really in production risk assessment guidance of the purpose-built blocks of flats guides, and certainly the principle which we would apply would be very much the PAS 79 approach to looking through this areas here. Now, it may be that actually your assessment of a building under the 2008 standard, you think, no, actually, this is really iffy. Well, if that's the case, then I think it's reasonable that we should try and reduce that risk. And it's no different to any risk assessment process which we would go through to ascertain whether a building requires further work. And we would use the principles there within PAS 79, and certainly the key bits here would be, do the fire precautions meet standards at the time of construction? Well, yes, they did. Then this is the understanding here is identifying the shortcomings in relation to current standards. Well, we know that because of the difference in calculations of escape routes. But perhaps then this is the interesting bit, is do the departures create current standards create unacceptable risk? Depending on the risk of the building, the height of the ceiling, other provisions we have, automatic fire detection sprinklers, I think it's going to be quite difficult to say absolute yes or no without understanding the context of the building. But of course, the fire risk assessment process then does give us options to either upgrade, maybe put in additional exits, which I would suggest is probably always going to be the safer option, obviously. But actually, it may be the case that it's considered adequate through that risk assessment process. So that's the approach really that you should be taking if you come across the differences and the difficulties of 2008 versus 2017. Now, we've spoken about the baseline provision as what 9999 would require, but we're just going to quickly look at the enhancements that are up there as well, the enhancements which are allowable, and some of things that you can obviously consider. Now, if you've got automatic fire detection and alarm system fitted, that can give you an additional 15% reduction in escape widths and extension of travel distances if there is a clear benefit. This is something which quite often gets forgotten. I see within fire strategies written that there's a very quick thing to say, well, it's got AFD, so that's absolutely fine, we get 15%. But there needs to be a demonstration of clear benefit. So particularly if you've got a very cellular design maybe, or multi-story what might need a CAT-M, but actually we can put an L2 system. If there's a clear benefit there, then we can allow 15% reduction. Also though, if you've got automatic fire detection fitted, you can also apply that same enhancement if you've got provision of a voice alarm system. So, and that voice alarm system can usually be of a clear benefit. I think you struggle to find a situation where it wouldn't provide a clear benefit. So that 15% actually can be applied as well. Something else you can look at is ceiling heights. So depending on how that ceiling is, you can then apply a percentage, same as the AFD with the 15, you can look at reduction in the escape width or increase in travel distance based on ceilings. So obviously the theory being that the smoke goes up quite high, got a long time before that smoke layer comes down and affects means of escape. But the key thing to remember though with applying any of these enhancements is that there are maximum limits. So look at table 15 and table 16 within 9999 to make sure that you don't exceed the maximum limits when looking to apply those those enhancements. Okay, so that's a bit of a whistle stop really to how the principles in which we would look to apply 9999 in a retrospective way for means of escape. Now I'm just going to take you through a couple of quick case studies to show you perhaps areas that didn't comply and the approach taken to it in ways that you can perhaps apply a bit of a fire engineered approach to something, and also just kind of understand how it can be applied. I've got two examples. They're both office buildings, but this first one's quite a small little office building. It's only 4 stories. You've just got the plan of it there on the right. It's single occupancy, and as most of these reviews, they wanted to understand the maximum capacity that they could realistically put within the building. I think it's worth just noting there that something we very much talk about with our reports when we're looking at occupancy is that it's usually something else which would actually limit the occupancy rather than 9999. It's quite often a health and safety or welfare issue that would, apply so many people per square metre, for example, just because of air conditioning requirements or something like that. Quite often that's more limited than what 9999 is. So we be very, very clear within a report that that's something else and other considerations. Certainly, there's also the potential argument whether or not building control needs to be informed. Is it or is it not a material alteration? We always advise clients to inform or go through a process with building control, and from my experience, half actually treat it as a material alteration and some don't. I would always play on the safe side, and I tend to always advise it is a material alteration, but half do, half don't in my experience. So anyway, this particular example we've got here is we had 2 unlobbied staircases. Now you can see one staircase here on this plan, just there. I'll show you the full plans in a minute. And we also had an external staircase, sorry, just there. See it there. The final exit from this staircase, however, was 750 millimeters, which, as we know, was an issue. However, when I undertook this review, this was on the 2008 guidance because the 2017 wasn't out at that time. So there you go. There's the full sort of layout of the building for these ones. So just show a bigger one of the ground floor. Sorry, it's first floor. So yeah, you've got the one staircase there, can sit unlobbied. You've got the typical floor plate which sits on the 3 upper floors, and a door which opens out there. Both outward opening, as you can see, but an external staircase sat just there. This window was fire resisting, incidentally, as well. And here's the ground floor. Now, here's a particular issue with this one, because this door here was 750 millimeters. But you may also notice as well that this door has got another door within the staircase which goes into a reception area. So this becomes quite relevant when we're looking to apply perhaps a little bit above and beyond what 9999 would allow. So there you go. There is the calculations for that building. Based on the width of the staircase, applying the limit here, based on a risk profile of A2, that's what each staircase would allow. Due to being unlobbied, obviously that's going to give us a staircase capacity of 336 because we discount one of the staircases. Arguably, one being an external, that's probably very unlikely to be compromised. But being that the internal's unlobbied, there's a potential that could be. So we're reducing that down to 336. But then we look at the story exit capacity based on what the door width of 820 mil, so it does comply. Opening up the staircase, it would actually give us a potential occupancy of 681, although one isn't reduced there, but it's not really. One more exit hasn't been discounted, but it's sort of irrelevant because ultimately the overarching occupancy there is that one, 336. So the limiting factor, as often is, was the staircase in this case. So applying the principles of what we've just spoken about, the limiting factor was the stair width, so 336 persons within the building. There was an L2 fire alarm system was provided through the building, but being so small and open plan, I really didn't think that it provided any clear benefit, to be perfectly honest, so we didn't apply the 15%. The big issue here really was the final exit door and the fact it was only 750 mil, where the stair was 110. Obviously, that's not great anyway. It wouldn't even comply with ADB. So how this got through, no idea. It wasn't that old, the building. But the key thing that we did acknowledge here, that there was an additional exit available from the stair to reception. Okay, not ideal, but ultimately, applying the design principle of one fire in one place at one time, if people are evacuating from the upper floors, if the fire's actually nicely within reception. That gives you a fair bit of time before that fire is going to impact on the staircase, although it's fair to acknowledge that the reception was incredibly low risk in this case. Or equally, if the fire's on the floor plate, there's no reason why that reception can't be used as additional means of escape. So that's the approach that we took when we looked at this one. So applying, the principles looking at what the staircase can actually handle. This was going a little bit into fire engineering principles very slightly, to be honest. But you can see there that table 7 from ADB versus table 13, it is very different in how it applies. Now, when you look at how a staircase works and the function of that staircase, unlike a horizontal exit, a staircase applies a storage capacity and a flow rate. That's how these numbers are derived. So in other words, how many people can we store in the staircase as well as flow into it? That's how staircase counts work. Now, within ADB, it's quite simple, because when you look at these numbers, they all go up on a uniform number. So for example, if we look at 1100 mil stairs, we know that 40 people per story the staircase can handle. We know that as storage, not flow. Where if we look at how it works in 9999, it's actually not uniform when we look at how it works over the floors. So the difference from here to here to here to here is different. So what we have to do is apply this calculation here to understand how many people we can store within the staircase. Now, the best way is to always work that at worst case. So we're looking at an A2 risk profile. So we know that the storage capacity between 1 and 2 means it's less people, so 45 people. That's worst case scenario. So we know that 9999 allows 45 people per story compared to ADB. So applying that principle, we know that the storage capacity of the staircase is around 135 persons. We also know that the stair capacity is 336. So if we take 336 and take away this number, that means that in order to clear the floor plates within the normal evacuation time of 2.5 minutes, we've actually got to have escape provision for 201 people at ground floor. So applying the 2008 standard, as we would have done at the time, and as we did because it was allowable, was that under 750 divided by 3.6, we do note that the minimum should be 800, would actually give us 208 persons on one door. We know that. But obviously, noting the fact that we got two 750 doors, we generally thought was allowable, for a case of 50 mil on a door, was given an escape capacity of 416 people. You can see that it's nearly double. It is double what's required. So it's over double from 201. So in this case, having the 1500 mil escape width was considered reasonable in this case, but absolutely clear to understand it wouldn't have been acceptable under the 2017 standard to do it in that way. But so if we look at the 2017, applying the same methodology, it would have given us escape capacity of 276 with these two doors. So we believe there'll still be a sufficient margin of safety within that number there to account for a 50mm difference, because we know that it might slow down fractionally, but not a great deal. So it's case study 1. That was really just homing around this particular issue around an area that didn't comply with the standard, but applying a bit of a fine-engineered approach, we can justify that in that case was okay. Second case study, a bit of a bigger building, this one. It's quite a large building. It's an 11-story office building. It's multi-occupancy, this one. That's a big difference. But again, they wanted to understand the maximum capacity. This particular one had a 4 lobbied staircase, all 1200 in width, and it had a sprinkler system as well. It's a phased evac building, and it had an L1 fire alarm with a VA system. And it also had a central atrium just here, which is actually very relevant. The client in this case occupied 4 floors. So within about midway out the building, they had 4 floors sharing part of the central atrium. But the baseline provisions, when we looked at what was physically there within the building, it actually complied. It was fine. There was actually no variation, I think, from 9999. But due to, I think, to the complexities in the building, rather than just a dip the toe in the water of management, this really required a full management audit to ascertain if they did comply to Section 4 of 9999. So this is what we come up to within the buildings. A1 risk profile due to sprinklers. So it's given us a 3.3, and that's what the staircase capacity was. Sorry, that's what story exits there were coming out to. So story exits were 374. So with 3, obviously taking out 1 staircase was giving you that per story. Then looking at stair capacity, again, same principles, but of course the key thing here was it was actually phase evacuation. So we're looking at 2 stories, so which would give us this number. Then divide that by 2, then you'd be looking at 830 persons per story. Okay, that's what your story capacity would have been in this building. But the key thing really what I wanted to highlight with this case study was the management issues. The management generally was pretty good, to be honest, but obviously when looking at a level 2 compliance, for compliance with the fire safety order, the atrium was fitted with these smoke curtains that you can see here. Being phased evacuation, they're a means escape system. And being a means escape system, we know that they should be tested weekly, but they were actually only being tested annually in this case. So I couldn't conclude that they were complying with the requirements of the fire safety order in this case. But generally, they could achieve 9999, had no issues with that, and it wasn't an issue, to be perfectly honest. The main issue was the management that was a concern. But due to this being phased evacuation as well, it wasn't really considered necessary to look at the other occupancies. If it's a simultaneous building, you would have to look at other occupancies in terms of ensuring that their numbers are okay. Their numbers are the same. Where phased evac, it was only actually evac in the client's affected floors at any one time, so the other areas wouldn't have applied. But certainly if you're simultaneous, you would need to really try and look at all the numbers of all the building. And there's the case studies, and that brings me to the end of the presentation. As Katie said, this is a pre-recorded session, but if there are any questions, then by all means get in touch either through Katie or myself, and be happy to answer them.
Brilliant. Thank you very much, Jamie, for that session today, and thank you for your time and your expertise on the subject. As Jamie's just reiterated, and as I said at the beginning, this is a pre-recorded session, so again, yes, do feel free to send any questions, because we do like to make these as interactive as possible. But obviously we appreciate today things are slightly different. But yeah, if you've got any questions on the comment, Jamie's email address is on the screen, or you can send them over to myself. That's absolutely fine. So what I'd like to do is, again, thank Jamie for his time. Thank you for joining us. Thank you for watching. This will be available on our YouTube channel as well afterwards, so feel free to share any content with colleagues who may benefit from this morning's presentation. But it just leaves me now to say thank you very much. New schedule of webinars for the new year will be available on our website shortly. We're just looking at just finalising a few to get online together. So when they're available, pop online and feel free to register into the next year. So thank you very much, and we'll see you soon.
Thank you.